In this video, we'll be looking at Chapter 11, Section C, on representing combined events. Let's consider all the possible outcomes for tossing two coins. First, we could get heads-heads. We could also get heads-tails. We could also get tails-heads. And we could get tails-tails. These four outcomes are what we call the sample space for the experiment. And the definition is really just the set of all possible outcomes. So we need to remember how to use set notation from Chapter 1 as we move through Chapter 11 on probability. Now, we can write the sample set using set notation, and we can use abbreviations for all the possible outcomes. For example, for two heads, we can write HH. For heads-tails, we can write HT, and then TH for tails-heads, and TT for tails-tails. And remember, we use the brackets for set notation. Now, there are four ways that we can represent sample spaces. The first is simply a list, and we saw that on the previous slide. The second is a 2D grid. The third is a tree diagram. And these two we'll go over in more detail. The fourth we've seen already from our study of Chapter 1 and Chapter 19 on Venn diagrams. We've already seen how to generate a list for a sample space, and we're pretty familiar with Venn diagrams, so the example problem is going to look at 2D grids and tree diagrams in a little bit more detail. Let's look at the two-coin example again. For this experiment, we want to list the sample space using both a 2D grid and a tree diagram. Let's look at the 2D grid first. Now, a 2D grid is a lot like other graphs that we're used to. It has an x-axis and a y-axis. And on the x-axis we can put coin 1, and on the y-axis we can put coin 2. We can also list all the possible outcomes for each of the coins. So we have heads and tails for coin 1, and we have heads and tails for coin 2. And now we can put a dot at the intersection of each of those possible outcomes. So one for heads heads, one for heads tails, one for tails heads, and one for tails tails. And this is my 2D grid. This gives us a quick visualization of how many outcomes are in our sample set. I have 4 dots, so there are 4 possible outcomes. Now let's take a look at a tree diagram. In a tree diagram, we're going to have 2 columns, one for coin 1 and one for coin 2. In the first column, we want to put all of the potential outcomes for coin 1. And if I flip a coin, I can get either heads or tails. And then, for each of those outcomes, we want to list all of the possible outcomes for coin 2. So if I flip a heads on coin 1, I could then flip a heads or a tails on coin 2. Likewise, if I flip a tails on coin 1, I could flip a heads or a tails on coin 2. And we connect those with branches, and this creates our tree diagram. Again, I have a quick visual representation of all the possible outcomes in our sample set. I have 4 ending branches here, which means I have 4 possible outcomes. And I just realized that I called this a tree diagram, so I'm going to erase that D right there and make it a tree diagram.